So as another example of Bayes' theorem and total probability, we're going to consider the following problem. Consider two boxes, one containing one black and one white marble, the other two black and one white marble. A box is selected at random, and a marble is drawn at random from the selected box. What is the probability that the marble is black? What is the probability that the first box was the one selected, given that the marble is white? So let's try to conceptualize this in terms of total probability and Bayes' theorem. So we do actually have a partition of all the outcomes of this experiment, and that partition has to do with which box was selected at the beginning at the start of the experiment. So we can think of all the outcomes in terms of the marble that's drawn as starting from either box 1 or box 2. So this outcomes either start with box 1 or box 2. And regardless of which one of those that you start with, you're interested in this event getting, for the first question, the event is getting a black marble. So black marble. And that can occur regardless of which box you draw. Okay, so let me conceptualize these boxes. So the first box is going to have one black and one white marble. So this first box has one black. Draw this black. And one white marble. So it looks like this. The second box has two black and one white marble. So box 2 has two black and one white marble. So let's first answer this first question about the probability that the marble is black that you get. And we need to separate that out into outcomes that started in box 1 and outcomes that started in box 2. So let's go ahead and do that. So the probability that the marble is black, let me use some shorthand. Let's let B1 be that you selected box 1, and B2 is that you selected box 2. And then just plain old B is that the marble drawn is black. So we're trying to calculate the total probability that the marble drawn is black, and that can happen in two ways. It's the probability that you selected box 1, B1, and the marble drawn from that box is black. Or, so we're going to add these, the probability that you selected box 2 and the marble drawn from box 2 is black. So those two pieces correspond to these disjoint sections of the event black marble. So this part is over here. Okay, so we're just going to break this down using multiplication rule. So the first probability is the probability of drawing box 1, picking box 1, times the probability that the marble is black. Remember, B stands for black marble, given that you chose box 1, plus the probability that you chose box 2. This is the other way you can get a black marble, times the probability the marble is black, given that you chose box 2. So we know that a box is selected at random, so that means you have a 1/2 chance of picking box 1, and also a 1/2 chance of picking box 2. Okay, the probability of getting a black marble, given that you're in box 1, if you know you're in box 1, you have this one black, one white. So you have a 1 out of 2 chance of getting a black marble, plus. If you're in box 2, the probability of getting a black marble given that you're in box 2, remember box 2 has two blacks and one white, so that is going to be 2 out of 3. So we do this arithmetic, I'm going to get 1/4, these 2's cancel, plus 1/3. If I get a common denominator of 12, I'm going to get 3 plus 4, or 7/12, is the total probability of getting a black marble, accounting for all the different ways that you can start. Okay, the second question says, what is the probability the first box was the one selected given that the marble is white? So this is the probability of B1 given white. So let's do part B. The probability of box 1 having been selected given that the marble is white. So this is a Bayes' theorem question. notice it is much easier to calculate the reverse probability, the probability of a white marble, given that you know you're in box 1. We know in box 1 there's a black and a white marble, so that probability would be half and be much simpler. Okay, so let's use Bayes' theorem. And actually first we'll just use conditional probability. So this is the probability of drawing box 1 and a white marble divided by the total probability of a white marble. Okay, and then the top becomes probability of picking box 1 times the probability of a white marble, given that you chose box 1. So there's a couple ways you can calculate the denominator. We already know that the probability of getting, the total probability of getting a black marble is 7/12. Because you can only at the end of the day get a black or a white marble, you can calculate the probability of a white marble as 1 minus the total probability of a black marble. Okay, and there's another way I'll indicate that you can do that as well. Probability of choosing box 1 then is a half. The probability of a white marble, given I chose box 1, is 1 white marble out of 2 marbles. And the bottom is going to be 1 minus 7/12. So I get 1/4 over 5/12. And if I flip and multiply, I'm going to get 1/4 times 12 over 5. And I can cancel. And I get 3/5.